In Shigley's example 13-6, we're focused on planetary gears, and we're told that a sun gear is driven clockwise at 100 RPM. The ring gear is held stationary, 0 RPM. We're told find the planet gear and arm, RPM, and direction. When they say direction, they mean clockwise or counterclockwise. So we have to set up a convention. So we're going to say clockwise is negative, counterclockwise is positive. So this one, the sun gear, would be negative 100 RPM because it's clockwise. Let's review some of the concepts around planetary gears. We have the ring gear, we have the sun gear, and then we have a planet. I made the sun a bit bigger so it shows up. Then we have the planet here. And then of course between the sun and the planet, we have the arm. We're going to number these, the sun as 2, the planet as 4, the ring as 5, and the arm as 3. The ring gear has a number of teeth associated with it, and in the problem here we're told it has 80 teeth, and we're told that the RPM is 0. The sun gear in the problem we're told has 20 teeth, and the RPM is negative 100. The arm, we don't know the RPM. That's the issue. That's the problem. And the planet, we don't know the RPM, but we know the teeth. Of course, the arm has no teeth. But the planet, we're told, has 30 teeth. Now let's redraw this gear train a little bit differently to visualize it. You have the sun gear, you have the planet gear, and if instead of making it a ring gear on the inside, you make it an outside, just for visualization, you have the ring gear, and they're all related by the arm. So we can develop some mathematical relationships using this schematic. Here we have gear mesh 1. For gear mesh 1, the ratio is going to be N2 over N4. Now they rotate 2 different directions, so we have to put a negative sign in there. Since we said that the sun is rotating clockwise and that's negative, we'll make the sun negative. So it's negative N2 over N4. So for this problem, we can solve that. We said the sun, N equals 20, and RPM equals negative 100. The planet, N equals 30. The RPM equals, that's one of the questions. The ring, N equals 80. RPM equals 0. So the gear mesh ratio for the first set, the first mesh, is negative 2/3. Now, with the law of gearing, we also know that the ratio of teeth is inversely proportional to the ratio of the speeds. This planet has to have the speed of the arm subtracted from it. So we define those speeds N2, 3, which is the speed of 2 relative to 3, and N4, 3, which is the speed of 4 relative to 3. That's inversely proportional, so I have to put the 4 on the top, and I'm going to call this one A for arm, just so we don't get confused. So N4A over N2A, and so that's N4 minus NA over N2 minus NA. And so I'm stuck here because I have an unknown. I don't know N4, I don't know NA. I do know E, it's negative 2/3, but I have one equation and 2 unknowns. Now, just for completion, I may not need it for this problem, but gear mesh 2, the ratio is going to be, the mesh ratio for gear mesh 2 is N4 over N5. There's no negative here because even though in this construction, you see the ring gear is going to be going this direction, that's inverted from real life. In real life, if the ring gear is going like this, it's going to be going like this, the opposite direction for the actual planetary gears. So gear 4 and gear 5 are going to be going the same direction. So for gear mesh 2, we have the number of teeth on 4 is 30, number of teeth on 5 is 80, so that's 3/8. And then for completion, that has to be equal to N5, the RPM with respect to the arm of gear 5 divided by the RPM of gear 4 with respect to the arm. So that's N5 minus NA over N4 minus NA. Again, we don't have N4 and we don't have NA, so we have 2 equations and 2 unknowns. Now let's look at the overall gear train analysis. The ratio of inputs to outputs should be mesh 1 times mesh 2. That's negative 2/3 times 3/8, negative 0.25. And then the E overall is also equal to the RPM of the last gear minus the RPM of the arm over the RPM of the first gear minus the RPM of the arm. Now, I know the RPM of the last gear is 0. I know the RPM of the first gear, negative 100. Then I know the overall efficiency, negative 0.25. So now I can calculate the RPM of the arm. This is just algebra. So we get the arm RPM is negative 20 RPM. The negative, again, means that it's clockwise. So now I've answered the first part of the problem. What's the arm RPM and direction? So it's 20 RPM clockwise. Now I need to find the planet gear, and the planet gear is part of gear mesh 1, so I can go back to my equation for gear mesh 1, and now I have this value for the arm, and I can use this equation to solve for N4, the planet RPM. So let me copy down that equation. So E1 is negative 2/3, N4 is what I'm solving for, minus a minus 20, N2 is minus 100, minus a minus 20, and then let's just do the algebra and solve for N4. So solving the algebra, N4 equals 160 minus 60 over 3 equals 100 over 3 equals 33.3 RPM, and that's positive, which means that's counterclockwise. So now we've solved everything. We've got the in value for the planet gear, 33.3 RPM counterclockwise because that's positive, and the arm we calculated to be 20 RPM clockwise. Again, the planet gear is rotating at 33.3 RPM counterclockwise, and we calculated the arm as rotating negative 20 RPM, which is 20 RPM clockwise.